Hi, I'm Hallie, and welcome to Project Str-Eng. Lots of questions surround the structures in our world, such as who made them, how they made them, and why they made them. And Project Str-Eng is our attempt at finding these answers through understanding structural engineering. In this episode, we're trying to understand failure. But first, let's talk about history. On a hot August day in 1907, a worker named Beauvais was driving divots into the southern span of the Quebec Bridge. Near the end of the day, he noticed that a rivet he had driven was split clean in two. Just as he went to report the news to his foreman, the sounds of twisting metal rang through the area, and the cantilever dropped out from under them. It crashed into the river below them with such great force, people in Quebec thought that an earthquake had hit. Did you know that Thomas Edison failed over 2,000 times before making his light bulb? To be specific, it took Edison 2,774 attempts before he decided to use this bamboo filament that allowed them to be a commercial success, as previous inventors were unable to put them into mass production. Edison's bulbs were able to burn for over 1,200 hours, and this triumph helped teach him 2,773 ways not to make a light bulb. He learned that in order to succeed, you have to learn from your failures. Anyways, thought to become one of engineering's wonders of the world, American designer and engineer Theodore Cooper was criticized by Robert Douglas, a Canadian government engineer, for his ideas. Cooper wanted to go with the cheapest route. In order to cut the cost of building the piers out further into the river, Cooper lengthened the bridge span from 490 meters to 550 meters. This would inevitably create higher stresses with the longer span required. So I guess the lesson here is, sometimes you gotta pay the price, or else you'll pay the price. Now I'll pass it off to Peyton with the interview.
Is that good?
Yeah.
You know how to cast one?
Don't you do like a little whoop?
No, you don't do that.
So, Hussein, what is failure?
Well, Peyton, in structural engineering, when we're looking at a structure and designing it, we have basically two hands. On one hand, you look at the demand, what we're asking the structure to do, and on the other hand, you look at resistance, how much that structure is able to withstand. Mm-hmm. And when your demand is greater than your resistance, that's when you get failure. There's the conventional sense where you see concrete flying, people dying. There's that conventional sense of the word failure, and that's what really makes the news and everybody looks at and thinks about. But there's also aspects to failure that we also take into account as engineers, and that's when we design something that doesn't fulfill its intended use. So if you're ever in a building where you feel excessive vibration.
Yeah, so you haven't failed at any project you've worked on, right?
I've come close. I was doing a bridge jacking a little while ago. So that's when you lift a bridge, change its bearings, and put it back down. So it was all overnight, and I was the engineer supervising the work, and I was there for the third night in a row. I ended up leaving for a split second to grab a coffee because it was about 4 a.m. The guy on site asked if he could remove some concrete underneath the jacks, but the jacks were still pressurized, and I didn't check that.
So pressurized meaning that
it was
holding
pushing up. So he wanted to take out the stuff in between the jack and the underside of the bridge. So as I come back, I see him chipping away at it, and then you hear a mini explosion because the concrete shattered.
Gosh.
His hand almost got caught in the thing, so he ended up breaking a finger.
That's crazy. That sounds like an epic fail.
I want to say nobody got hurt, but that's not true.
Yeah, it's not true.
All it takes is a split second of letting your
not
guard
having
down.
coffee. You know what I like to
not
say?
having coffee.
Don't talk to me unless I've had my coffee.
That's why
and
I say that now.
think that's just how you should carry yourself around in the world. What's the worst example of a failure in structural engineering, like in history? Like one that's like, bro, if I was there, none of that would have happened.
I mean, there's tons of failure in history. One of my personal favorites, it was a suspension bridge called the Tacoma Narrows Bridge. It was built in 1940 and collapsed 4 months after. And the reason why it collapsed had nothing to do with the vehicles on it.
Okay.
It was the fact that the wind blowing on this suspension bridge matched its natural frequency. So if you're to think of, for example, a swing, and if you catch the right rhythm, you see it amplifying with not necessarily too much force. that's matching the natural frequency.
Okay.
So if you catch the right rhythm
Yeah.
for the frequency, then you end up amplifying things. And what
Stop.
happened was the wind matched the frequency of this bridge, and nobody
That's
checked that.
insane.
And so with a little bit of wind, the bridge started going.
What would you have done differently with the suspension bridge? You would have just been like, guys, the wind.
Well, what you're supposed to do,
Like pretend you were in 1940 and you were like there on site.
well, what you're
like,
supposed
"Yo."
to do is you're supposed to do scale model testing. You're supposed to blow air or water at it, whatever, a fluid, and figure out what the natural frequency is, make sure your bridge is outside that likely natural frequency so that those things don't happen.
Okay.
We do that in tall buildings too,
Like if the swaying of the building matches the wind, it would just fall over.
with very little force, yes.
Wow.
So you don't need very much. Again, think of a swing.
Yeah.
If you're out of rhythm, you stop it.
Yeah.
If you're in rhythm, you don't need to push it very hard for it to keep getting higher and higher.
Did you catch anything yet?
No, not yet.
Nothing? Look at what I've caught.
You know, nothing is safe from failure. My experience with failure is it's rarely ever one thing. It's usually a series of unfortunate events.
Except with the finger.
Except for the what?
The finger guy.
The finger guy.
That was just
that
like
was completely on me.
That was just your fault. And it was the one thing you shouldn't have done and you did it and he broke his finger.
He actually called me the next day and he goes, they had to amputate my finger. And I remember sitting on the phone going,
I would have thrown up.
and then he's like, I'm just kidding, I'm coming to site. I'm like, "But so whenever we do anything, the risk of it failing is never zero, no matter how well engineered it is or whatnot. What we do is we minimize that risk to what we say is an acceptable level. And sometimes you just take the chance. So for example, when you're dealing with sinkholes, to go through and fully map out all the soil within a big project is virtually
Yeah.
impossible. So what
Yeah.
you do is you do enough work to say there's very likely a chance that it's not going to happen. And if it does, you deal with it.
Yeah.
So basically, structural failure refers to the loss of structural integrity or the loss of load carrying capacity in either a structural component or the structure itself. Structural integrity and failure is an aspect of engineering that deals with the ability of a structure to support a designed structural load without breaking. Structural failure is initiated when a material is stressed beyond its strength limit, causing fracture or excessive deformations. Does your brain feel bigger after this? I know mine does. Thanks for tuning in. Make sure to smash that like and subscribe button on your way out. And as always, enjoy the process. I need your help.
Oh,
It's too much.
it's too much.
That looks like a big one. Is that dinner for all of us?